Hey everybody, welcome back to Tech Blick Conference. I'm joined here. This is a talk I'm really looking forward to. Mike Mastropietro, I've known him a long time. He's the VP of Engineering for ACI Materials. He's going to talk about a new development, the Alchemy Conductive Inks. In his talk, introducing ACI Alchemy Conductive Inks, enabling flexible and 3D electronics. If you have any questions, by the way, please put them in the chat to the right. I'll also put a note there for that. Anyway, you're on, Mike.
All right, thanks, Dave. For those of you who don't know who ACI Materials are, we're a small materials company located in Goleta, California. It's Santa Barbara County. We've been in business for 8 years, started around aerospace coatings, inorganic aerospace coatings that can survive re-entry, and then have gone into electronic materials about 4 years ago, and now we're focused on manufacturing high-performance functional materials. Really what differentiates us from other material suppliers is that we have a patented hydrodynamic cavitation dispersion process that uniquely allows us to disperse viscous materials compared to all other known forms of hydrodynamic cavitation. And that combined with innovative formulation know-how allows us to produce superior materials. And you'll learn about one of those sets of material in this talk. The image over the left is showing how this dispersion process is different than traditional dispersion processes. And if you're interested in more on that, you go to our website or reach out to us. And we also apply this technology to strengthening 3D printing materials, and it can really be applied to almost anything. So please reach out if you're interested in that. This talk will be focused on a new series of conductive inks that we are launching called the Alchemy Conductive Inks series. And we'll talk about some of the benefits of those, some examples in use, and partnership opportunities on some series of those that are still under development. So before going into what makes these better, it's always helpful to understand what you have now. And a lot of people, their conductive ink is just sort of a black box and they don't really understand how it works. And so this slide is showing the traditional polymer thick film silver sort of conductor, or a percolation type conductor, where you have your conductive fillers in a thermoplastic polymer dissolved in a solvent. You dry it, you force your particles together, but the problem is you always have this contact resistance. The upside is you get good resin interface at the substrate interface, which results in good adhesion, but your electrical performance tends to be, at best maybe 10 times that of a bulk conductor like silver copper. And so more recently, over the past, say, 20 years, and this is how I got started in this business, is Centerable Conductors. Centerable conductors are different in that you have your wet ink, you dry it, your particles come together, but then under the effect of thermal energy, they actually center together. So you avoid that contact resistance you see with the classic conductors, but the challenge is getting resin to the interface without preventing sintering. And so these are the current classes that have been available to people doing flexible hybrid electronics and printed electronics. And that was until, ACI is about to release what we're calling the ACI Alchemy Conductive Inks. And the name Alchemy comes from, as you look at the resistivity of traditional PTF inks, they're about that of lead at about 19 microamp centimeters, or 15 milliohms per square per mil. And now we're able to have the ease of use and curing and process speed of a polymer thick film, but with the electrical conductivity of sintering inks, or much closer to the precious metal itself. And so that's where the name came from. And so we'll talk about some of the key benefits of these materials in some of the next slides. And again, tying back to why we're able to do this, to give you a picture in your mind, is so we sort of have this hybrid or semi-sintering conductor. So we have our microparticles like a traditional ink, and we have our nanoparticles like a sintering ink or some sorts of sintering inks. And so we're able to get sintering, yet we have resin at the interface. And so you kind of get the